All right, so we're going to start up now on our third section on viruses. And what we're kind of looking at in this section is an example of a virus that has the ability to become lysogenic, but then switch back over to being lytic if needed, which is kind of a cool thing to be able to do if you're a virus. So this particular virus, again, is a bacteriophage, and it's going to affect a bacteria called Escherichia coli, or E. coli for short, which I'm sure most of you have heard of. But E. coli is a bacterium that lives in the large intestine of humans, and it itself is subject to infection by this particular virus. So when this virus infects an E. coli bacterium, it will either go into a lytic phase or lysogenic phase, depending on which genes are expressed. Now, if it becomes lysogenic, then of course it's going to put its DNA into the DNA of its host, and every time that host divides, it'll pass on some viral DNA to all of its offspring as well. If conditions become stressful, such that the bacteria is in danger of maybe dying off or not performing as well as it should be, or something like that, then the virus is actually going to do a phenomenon called induction. Now, induction this is first off a very different induction from the induction we saw back in our first chapter, all the way back during the first week of class. We talked about inductive and deductive reasoning. This is a very, very different kind of induction. Right? This induction means the virus is going to go from being lysogenic to becoming lytic. All right. So what can happen then is that when this lysogenic bacterium, or lysogenic virus, which lives in a bacterium rather, becomes lytic, every single bacterium that has that viral DNA is going to eventually be destroyed and release the viruses it contains into the world around it, where you're going to have then a massive infection of other bacteria in the surrounding environment. All right, so this really, from a survival standpoint, is really a good idea for the virus because, if you're lysogenic, you don't have to worry about finding a new host because your DNA is already part of a line of host cells to begin with. But B, if that host becomes stressed and is in danger of dying, you can then switch back to lytic, release a bunch of viruses because chances are the bacterium is going to die anyway. And those viruses that get out there and can infect new bacteria can pass on your genes. So it's really kind of like a best of both worlds situation for that virus. And so this is kind of what it looks like. We talked about our 5 phases of the lytic cycle, right? So we have our attachment, our injection or penetration phase, synthesis phase, assembly phase, and then release. And then new viruses are able to go out, attach to new bacteria, inject new DNA, and so forth, and complete the cycle or perpetuate the cycle. Now, if when that DNA is infected or injected into the cell, rather than going on straight to synthesis, we do this kind of a thing. So now the viral DNA goes into the bacterial DNA, and so when this bacterium divides, it takes viral DNA with it. And so you might build up a population of, a million bacteria that each one has a bit of viral DNA. This just keeps perpetuating itself until something happens when the bacteria becomes stressed. Then the viruses switch back to being lytic. They start synthesizing new viral components, DNA, RNA, protein, whatever, and they're assembled into new viruses. New viruses are released, massive numbers of bacteria die off, and huge numbers of viruses are released into the environment. All right, so again, best of both worlds. If you're a virus, you get the stowaway aspect of being lysogenic, but when conditions turn tough, then you can switch over to becoming lytic again. All right, so just a few examples. These next 2 slides have some examples of some fairly important human viruses or diseases caused by viruses. So chickenpox, which is also, when it changes over time, it becomes the virus that becomes shingles or can cause shingles. So everybody that has been infected with chickenpox or everyone who's been vaccinated against chickenpox currently still has the virus in their body. Body never really gets rid of the virus. It just exists in low levels in the body. And the body's immune system is pretty good at keeping it in check, so it doesn't really get to the point where it makes us sick again and we start showing chickenpox symptoms again. But the virus is in our body until we die, once we've had it. Either way, if we got it naturally or whether we got it through vaccination, the virus is still in the body. And if it changes, if it mutates, it could become the shingles virus and then cause a whole new set of symptoms, which are not very pleasant to deal with. Hepatitis B is a virus that affects the liver, causes liver damage there, can be fatal. Herpes, which there's genital herpes, there's all kinds of other herpes viruses as well, which, again, you don't cure these. They go into typically latent periods where, they don't show symptoms, they don't express symptoms in a host, but they're still there in the body, and they can pop back up again over time. This is extremely, extremely prevalent. I think it's something like 1 in 3 people at some point during their lives will eventually pick up a form of herpes simplex virus. Not necessarily genital herpes, but cold sore, those kinds of things are very, very common in the population. Mononucleosis is a virus that infects macrophages inside your bodies. These are immune cells. Normally, actually, they affect monocytes, and then monocytes become macrophages. But either way, they kill off these immune cells, which is going to essentially cause you to become immunocompromised while you have it, make you more likely to pick up other infections that can become established and those kinds of things. Smallpox was historically a really, really important disease in people, but the smallpox virus back in the late 70s more or less eliminated it from at least natural spread worldwide. So that one, historically, probably millions and millions of people died of smallpox before that virus was controlled using a vaccine. AIDS, which is caused by HIV, we're going to talk about that one a bit later on as well. We'll talk about some specific aspects of that one. Polio we already covered as well back early on in this chapter. Yellow fever is an emerging virus. This one actually has a really high mortality rate, potentially of up around 60% or so, which is pretty high. Not as high as Ebola, but still pretty high. And very much tropical in nature, carried by mosquitoes. Very, very dangerous if it's introduced into a human. Ebola, which is a lot of times you hear some really scary stuff about Ebola because it does have a mortality rate upwards of 90%, but that's in very rural areas of Africa where people don't necessarily get a lot of treatment for it, and they don't have access to treatment for it. And when people die from it, people don't necessarily always handle the body in the correct way, so it tends to spread that way as well. Now, the thing with Ebola is that despite what you hear about it, it doesn't really spread that easily. All right, so when you're looking at a virus and how dangerous it might be, the two things you want to look at are, all right, what's the mortality rate and how easily is it spread? Well, clearly Ebola has a mortality rate of 90%. That's higher than almost any other virus. But it's almost hard to get Ebola if you take the right precautions for it. So if you come into direct bodily fluid contact with somebody who's had the disease, there's a pretty good chance you might get it. But if you take some basic precautions, if you're a healthcare professional, if you're a family member, to not come into contact with that bodily fluid, then it's a really, really good chance you're not going to get it. And even if you do get it, it is treatable. If you have medical resources available to you, it is treatable. Now, again, in Africa, where this tends to occur in the kind of the worst scenario cases, people are often very, very far away from hospitals, or they can't afford medical treatment, so it tends to have really high mortality there. But a few years ago in the U.S., when a couple people picked up Ebola, it was treatable, and so it's not as scary as what it's sometimes made out to be, I guess is what I'm getting at. Influenza, of all the viral diseases, and really almost any other disease, period, is historically the most important killer of people worldwide. All right, so we'll talk about influenza a bit more in the upcoming sections, but back in the year between 1918 and 1919, it's estimated that upwards of 50 million people died worldwide of influenza. Now, 50 million people back then is a lot different than 50 million people now. Back then, there weren't 7.5 billion people on the planet. So losing 50 million out of maybe a couple of billion total people was a huge hit to the world population back in that span. Flu virus tends to mutate relatively quickly, which is the reason why, we have flu vaccines, but they also have to change every year as the virus changes every year as well. So it's a really difficult one that we almost never hear about anymore, and people don't really think about it, people don't really worry about it, because it's always been around, and it's not new, it's not exciting, it's not exotic, and people just tend to forget about it, even though it can be very, very dangerous, depending on what kind of strain you pick up. Measles, again, historically was more or less eradicated. Of course, that one has made a comeback now because of people's decisions at times to not vaccinate their kids. Measles has made a bit of a comeback in a lot of the world, but it is one that is relatively controllable with a vaccine. SARS is another type of coronavirus that we talked about before a little bit in the previous section, but back in the early 2000s, SARS was kind of like the precursor almost to what the COVID-19 virus became in 2020. They are related viruses. They're both classified as coronaviruses. Even though they're not the same thing, they're relatively closely related. Now, the SARS virus didn't really spread all that easily like people thought it would initially when it was first discovered. It did have a fairly high mortality rate, but it just was one that was not really all that easily spread. Now, COVID, on the other hand, different story. That one spreads relatively easily.